Well, hey friends, Graham here, XFO Audio. I'm an audio designer, but I wasn't born an audio designer. Since this is my first product, I want to introduce myself and tell you where I'm coming from a little bit as an audio designer. One person in my life said, "Why did you wait until you were in your mid-40s to start down this path?" And I think a really good way of answering that is that I needed to spend 25 years, 30 years cataloging experience that gave me the information needed to know why I had to build this, why I needed to build it in the way that I did. And that comes in part from a genuine respect and nostalgia for the quality of manufacturing that the United States and other countries were capable of in the 50s, 60s, and 70s, before that even, but before the motives became profit and the manufacturing processes started focusing on the addition of features and the decrease of quality, and the maximization of profit. And so I'm not approaching this from a standpoint of profit. I'm approaching this from a standpoint of building equipment that's up to the standards of how gear was built that I still use today. Langevin AM16, MCI JH16, 24-track 2-inch tape machine. Those machines were built to be the best that they possibly could. They were built to include schematics and service manuals for the owners. They were anticipating that the owners would know how to do some very minimal maintenance and repair. And so everything was accessible, everything was removable, everything was repairable, everything was maintainable, and everything was built to the very highest possible quality standards. And one of the key words is discrete, where every component in a circuit was generally made up of one device that had one job. And so that's the difference between a circuit that uses only bipolar junction transistors and a circuit that uses integrated circuit chips that has like 100 bipolar junction transistors inside it that are microscopic. And that's where I'm coming from, is I needed to learn the hard way why gear needs to be built like this and why that's what I consider my calling at this point. And so I'm thrilled to introduce to you the John Hall AM16 mic preamp. But it's not only a mic preamp, it's also a line amp and a booster amp. So this can function as a passive summing amp, like a Neve type summing circuit. So these work excellent in a broad range of purposes, and so they're really just a gain block that you can use as a mic amp, you can use as a line amp, you can use as a booster amp. And the audio quality is absolutely no compromise. It's all discrete, it's all Class A. I used the best possible components that I could. I built the best possible power supply that I could. One thing that I love to point out is that the power supply's power transformer is external to the chassis, and that's for noise reasons. You need to have your critical amplification circuits as far away from as possible from your power transformers. And one of the things to think about as a designer and as a customer and as a recording engineer is that if a piece of gear has a power transformer inside it, its own circuitry may be able to reject the noise that it's creating, but your unit directly on top of it might not be able to reject that noise. And so there are parasitic noise bleeds from pieces of gear in a rack, and so you have to be careful about how you rack your gear. And when you hear ground hum, you've got to figure out where it's coming from. So you got to figure out what's noisy. You know, hold your mic up to different things and figure out where noise is coming from, and you can get away from it. So let's start talking about the John Hall AM16. I've got my oscilloscope on. It's making a little bit of noise. This is one of my favorite mics. It's a Groove tube condenser. It's not super hyped, but I do love the sound that it gets. And so I'm pairing it today with the John Hall. The left channel has the tube condenser, and the right channel has the square wave. And so as I'll press both buttons to change what the mic is doing, and you'll also see, hopefully, what it's doing on the oscilloscope. If I can be careful about my placement of everything. So the left side of the square wave has a large spike, and that's a high frequency boost that's caused by the 600 ohm output feeding a high impedance input. And so a 600 ohm output needs to have a loading resistor. So this first button that we're going to experiment with is the 680 load. And when you push that in, the high frequencies become flat, and the square wave on the oscilloscope becomes flat. You will notice that not only did the high frequencies decrease, but there was also just like almost like an overall gain decrease. So let's take that loading resistor back out, and now we've got more gain. We've got a lot more high-end information. There's a lot more sibilance that's not aggressive or nasty. When it's transformer high frequency ringing, it's way up in the air region, which is not something that most high boost EQs can do. This is really just like a passive high frequency exciter when you don't have the load resistor in. And when you do have the load resistor in, you have a flat frequency response, and that may be what you want for an instrument that already has a lot of high end in it. But if you're really trying to put a vocal on top of the mix, that might be the one instrument in your mix that you leave the loading resistor out on while you're tracking it, so that that air and that top end puts that instrument at the top of your mix when all is said and done. I hope that makes sense. But the loading resistor and the way that you can play with high frequency ringing on the output transformer of a 600 ohm matched impedance unit like this is really fun and really useful in the studio, and it's one of the things that I truly love about using an AM16. This is the 20 decibel pad. You'll notice that I've gotten a lot quieter. I can really lean into it to get about the same. So a 20 decibel pad is a heavy pad. It's a big pad. But the reason that we use a 20 dB pad on the mic input is because that preserves the impedances on the front end. And that's important to preserving the tone of your mic and the tone of the preamp. We've got a final switch down here that changes the output transformers ratio from 1 to 2 when it's out. So that's max gain when all buttons are out. When you push in this bottom transformer ratio switch, everything gets a little quieter because you've change the output ratio and you're not using the free gain of the output transformer. You're just passing through in a 1-to-1 ratio instead of a 1-to-2 ratio. So that might be what it takes to get the volume right for the singer that you're working with. But if they're a real whisperer or close to the mic, all buttons out. Phantom power up top. It does have LED indication. I'm not going to turn it on because I don't want to disrupt the oscilloscope or my microphone, since it's a tube power supplied mic. So that's an introduction to the John Hall AM16. I could go on and on about sourcing the very best 1% resistors that I could, gain matching all of the transistor pairs as they boost the signal, and in the Darlington pair and things at the end. So input transistors, output transistors, pairs matched to gain. What else can I tell you? These are sealed C and K switches. The circuit of the AM16 has 0 electrolytic capacitors in it. There is one capacitor here for the phantom power, and that's an easy swap 20 years from now if you need to. And I built the power supply to be as easy to maintain as possible 20 years from now when it's time to recap your power supply as well. The input and output transformers are manufactured by Cinemag. Cinemag made the transformers for Langevin products originally. There's a lineage there of Ed and Dan Reichenbach. David Jaron now owns Cinemag. And I really like working with Cinemag, and I think those transformers sound the best. This tube microphone actually has a Cinemag transformer in it. And I think that that's part of why this has always been my favorite microphone, even though it wasn't a particularly expensive one. I hope that answers most of your initial questions about using a John Hall AM16. It's a fixed gain preamp, meaning you can really saturate the input transformer. And then with this combination of switches, and if your mic has a pad as well, you definitely have 12 to 15 different steps of gain that you can access through different combinations of buttons and things. That's it for now. Graham, XFO Audio. Want to thank everyone for watching, and please subscribe and stay tuned for more products like a stepped output attenuator that you can put next in the chain on this, and lots of other fun stuff too. So thanks for watching. We'll see ya.